Hello, good morning or good afternoon, everyone, and welcome to the first webinar of our 2024 Java Card Forum webinar series. Today webinars is a talk on Java Card Stepping Stones from Amedeo of STMicroelectronics, and Amedeo is also the chair of the Interoperability group at the Trusted Connectivity Alliance. Amedeo is a senior technical project manager and is a team leader at STMicroelectronics for the development of telecom and mobile devices, including embedded SIMs and secure elements. Today, the embedded SIM form factor is increasingly available and replaces removable SIMs in mobile phones. In embedded SIM, operators are able to share the SIM embedded in the mobile phone and download their connectivity profiles, including Java Card or SIM toolkit applets that can be in the profile, which in the end result in an embedded SIM with several operator profiles and several applets running in parallel. And the sharing of the SIM by applets from different operators pose tremendous challenges, which have been addressed at the Trusted Connectivity Alliance and will be presented now by Amedeo. You will be able to ask questions right after the presentation, but if you cannot wait, you will be also able to post your question in the chat. And note that this presentation is recorded and will be available on our YouTube channel, and you have a link to the YouTube channel also from the Java Card Forum website. And now, without any further delay, please welcome Amedeo. And Amedeo, the screen is yours.
That's great. Thank you for the great introduction, Gian Daniele, and thank you all for your participation. It's really an honor to open this series of webinars for the Java Card Forum. So it's really a big emotion for me. So great. Thank you for this. So as Gian Daniele introduced, I'm in STMicroelectronics as a senior manager since more than 20 years. And I'm also serving as the chair of the Interoperability Working Group from the Trusted Connectivity Alliance. So if you don't know it, if you're not familiar, Trusted Connectivity Alliance is a global industry association. We are working to drive the sustained growth of a connected society through trusted connectivity. We do this by leveraging our member expertise to enable all stakeholders across society to benefit from secure and interoperable connectivity solutions. The solutions span tamper-resistant element or theory technologies that includes SIM, embedded SIM, integrated SIM, embedded secure element, integrated secure element. So all the flavors of last mile security that we provide to our stakeholders. And we also provide as TCA members as hardware and of our devices and for remote management and personalization services, so things like that. We work basically with four main, let's say, assets in four main ways. For sure, we work a lot with the other technical associations and standard bodies, including the Java Card Forum, to support the continued standardizations of the technologies that evolve around our products and our theory. We also provide exclusive statistical insight into the embedded SIM ecosystem based on members' market and actual shipment data. So from time to time, we publish some reports that contain a lot of useful information about the trends of our market based on actual data. And we work with, we develop some of specific document for specifications and interoperability, like the stepping stones that I'm presenting today, or the interoperable profile package format that is the format defining how you which is the format of the subscription that you download on your device in the embedded SIM embedded SIM ecosystem. And we provide educational information to support our stakeholders to understand the characteristics and to improve their working within the embedded SIM and the TRE ecosystem. Our members are, you see them, they are really industry-leading providers of embedded SIM solution. We have a global market footprint of over 80%. This is, of course, important from a market standpoint, but today I would like to focus the relevance of representing such massive market share related to interoperability. In fact, in my team, Interoperability Working Group, we have experts from all of those companies, and we verify that the solutions that are defined as interoperable are actually interoperable with the products from our members. So if you are interoperable with the solutions provided by TCA, at the end, you are interoperable with the 80% of the market. That is for sure a sound number. So it's an important reference also in terms of interoperability and of technical solution. At the let's say the center of our art and of our environment is, of course, the tamper-resistant element, so the TRE. You are probably very familiar with the various form factors that the industry has provided in the past and is continuing to provide, and also with the most recent ones. For sure, TCA started with the SIM technology. A few years ago, let's say our previous name was SIM Alliance, that can be in the various form factor of 2FF, 3FF, or nano SIM, and it's the replaceable hardware that enables connectivity to the cellular network owned by the mobile network operators. So it's really the starting point of our story. Then it has, for convenience, for management, for easiness of logistics and so on, it has migrated to the concept of embedded SIM or eSIM that is a solderable form factor, typically according to ETSI standard MFF, or even to other form factors like the WSSP, capable to host multiple connectivity profile as defined by GSMA, and capable to support over-the-air remote SIM provisioning. In the last, let's say, of the family is the integrated SIM, that is a new form factor, where the embedded SIM operating system is loaded on hardware IP that is integrated within a larger system on chip, typically that has also some other functionalities like a modem or an NFC controller and so on. This is beneficial for thinner, smaller, and more power-sensitive devices. So it's really the last evolution of our family. And while, let's say, the form factor has evolved over the years, probably even bigger has been the evolution of the embedded SIM ecosystem that has seen in the recent years a heavy investment in terms of global infrastructure, both on the device side, on the eSIM, on the mobile phone and so on, but also on the remote platforms called the subscription manager platform. In fact, now we have a global infrastructure that allows users to connect to more than one operator and allows seamless switching between mobile operators without changing the SIM card in the device. Altogether, mobile operators, device manufacturers, service provider, operating system developers, we have all, let's say, embraced and developed the eSIM technology because it's, let's say, with not so many doubt, that is a globally reliable and flexible connectivity provider. So at the end, it works really in many regions on the world. It is designed according to the most severe and validated security protocols, like most of the technology for the smart card, but the SIM is not an exception. It provides end-to-end digitalization. It has an improved sustainability because you don't have anymore of removing a physical device when you want to change your telecom operator, and it's a little bit more apt and more proven for device evolution, because the capabilities of changing the operating system, changing the embedded SIM profile on the embedded SIM is a key asset for providing new services and for enabling such services even after the product has been deployed on the field. So at the heart of the embedded SIM evolution, there is for sure the GSMA, the Global Industry Association, that over the years have created several remote SIM provisioning specifications. The first one was the embedded SIM for the machine-to-machine that addresses devices where profiles are managed remotely and has had strong success, especially in the automotive market, but not only, also in other sectors. It was then joined as a new standard from GSMA by the specification for the consumer device, the SGP22, that addresses smartphones and other consumer devices where the end user activates the profile of switch operator. So it's so-called an attended solution, meaning that there is a person that express an intent, and the device captures this user intent and perform the operation of changing operator, installing a new subscription, and so on, executing on the embedded SIM. And recently, GSMA has provided a new solution for the IoT that is dedicated for remotely provisioning and managing Internet of Things devices. This is, of course, let's see, we have a lot of expectations for this standard as the TCA because the number of IoT devices that can be enriched and augmented by an embedded SIM connectivity is impressive. And GSMA has provided a new standard that is scalable, fitting several IoT requirements, as requirements also for power consumption and so on. So it is more fitting the IoT ecosystem requirements than the current specifications on consumer and machine-to-machine. And we really believe that this would be a huge success for the connectivity of the IoT devices. In addition to that, GSMA has developed another transversal specification. Transversal meaning that it works for IoT, for consumer, and for machine-to-machine, called Secured Applications for Mobile, or SAM. That is a new concept of a security domain inside the embedded ESIC. A security domain is a safe container of applications with remote management capabilities. The characteristic, let's say the unique characteristic of this SAM concept is that such applications are available regardless of the telecom operator that is currently activated, so the operator profile that is used. This for us means an important, let's say, opportunity to support new use cases using an hardware that is the embedded SIM that is security certified. It's typically based on secure hardware. It has reliable technologies, field proven, and so on. It means on the other side that on the embedded SIM we are downloading new use cases for banking, by which the end user can leverage the payment applications installed in the device and use the secure element as and the applications in the SAM as the security element of the authentication, the transit applications. So for in a similar way for executing contactless payment and other mobility services, and the ID application for mobile ID applications, from federations to government and so on, always leveraging on the security certifications that the embedded SIM is certified accordingly, and the IoT safe specification, that is another standard from GSMA, enabling IoT device manufacturer to set up secure channels with between IoT device and the cloud, relying on the embedded SIM as a robust, scalable, and standardized hardware root of trust. So the embedded SIM, the application inside the SAM security domain operates as a root of trust. On one side, this is fantastic. It's brilliant. So we have the eSIM at the center of the secure ecosystem of applications that goes also beyond the telecom. On the other side, it's also a challenge for interoperability, because on the embedded SIM product, we need to host applications that come from various markets and from various ecosystem that are probably not, let's say, have not been fully exposed to the characteristics of the eSIM ecosystem and of the telecom applications in general. So if on one side this is a great opportunity for us, on the other side it's also an interoperability challenge, the integration of such application. And the other concept that is a little bit justifying our effort in interoperability is the great success of the SIM technology that we are seeing now, and that we expect to see even more in the future. This is a picture of, it's a figure of 2023, in which you can see that basically the number of consumer eSIM profile downloads has more than doubled in just 1 year. And the reason is that in some specific region, like especially in North America, we have seen an increased penetration of smartphones that have only the embedded SIM, so that they do not have anymore the SIM slot, the SIM tray. And so, of course, this accelerated the usage by the user of the eSIM technology. Generally, and this change of paradigm has already happened in North America, but we expect it will soon happen also in other in other regions of the world. Generally, worldwide, we have seen broader availability of eSIM-enabled devices. In the past, it was mostly high-end device. Now, it's not necessarily true anymore. And we also see an increase of international travels that in 2024 is expected to go beyond pre-COVID numbers, the level of travels. So this is, of course, another driver for the embedded SIM, because while traveling is typically convenient to have multiple operators for the various countries. So all of those justify, and we see the numbers, an increase of the embedded SIM success, but also anticipate an even further increase. This is for the consumer. In the same trend we see for the M2M, where in 2023 we saw an increase of subscription management platforms of more than 10%. This means that more players are coming to the ecosystem, and so at the end the technology is growing. And as already anticipated, we expect a big jump on the embedded SIM related to the IoT, because we have a new standards because for the IoT, because not the consumer, not the M2M, we're really addressing all the needs and the questions coming from the IoT market. The embedded SIM for the IoT has been designed for that. So we expect that IoT devices will be powered by this embedded SIM in the upcoming years. But this big success, again, is a great success, is a very positive thing, but it also had an interoperability challenge because we have more companies and we will have even more with the IoT. We have participants that were not naturally, let's say, coming from the telecom ecosystem, from the SIM market. We have devices, eSIM enabled, that are very different each other. No, we see a car, a smartwatch, a mobile phone, a computer in the screen. So devices that have different requirements in terms of lifetime, of quality, of reliability, even of level of service, and so on. And we have telecom operators that have to develop their profiles and include Java Card applications developed by Java Card application providers in their profile, with the assumption that they are not, they don't know for sure on which kind of device typically the profile will be downloaded. So their application needs to work and to be interoperable with a higher variety of devices compared to the previous landscape of the SIM technology. So the interoperability challenge is much greater due to the new actors that are coming, to the diversity of devices for embedded SIM, and to the profiles that from telecom operators have to be deployed on multiple devices. To answer to this demand, the TCA has worked in this year to develop a new document called the Stepping Stones for Java Card Developers. The document has been developed by a series of a team of experts from the various TCA members, and the main source of information for this kind of document has been the experience of the companies that are from TCA, and in particular the issues that we faced of interoperability during the last years of the lifetime of the embedded SIM technology. So we took benefit of the integrations that the TCA members performed around the world with all the devices in the various ecosystems, from automotive to consumer and so on. And we summarized the most important practices that are useful for Java Card developers to avoid such kind of issues in interoperability. So the document is really written by the experts with the experience, based on the experience done on the field. The document also contains an analysis of the technology updates related to the Java Card technology. We will see quite soon, and a checklist that summarizes the various challenges and interoperability suggestions to be sure that developers are, let's say, keep this list under control. It's not the first time that we do that. We started actually more than 20 years ago with the Java Card technology, and the Interoperability Working Group has maintained this series of over the years, starting with the Java Card, but continuing with NFC, Smart Card Web Server, and Mobile Connect, knowing that interoperability is not a destination, it's a journey, because we continue to add new features and new services to our beloved TRE. And for that, we know that we face even always new interoperability challenges. That's why it's more than 20 years that the group is providing its experience and support to boost the interoperability of the ecosystem. So the first part of the document, and I will go now a little bit into the content of the document. So the first part of the document is about the most recent updates for the technology related to the Java Card. And of course, we had to start with the new version of the Java card, that is the 3.2. So of course, Java card as you all know, I mean, the Java card has had a tremendous leap with the version 3.1.0 that is referenced in our products. With the 3.2, we expand the horizon for support for security algorithm, for improved cryptographic operations and performance, and for integration of biometric templates. Some of those information are highlighted in the stepping stones, and of course, it is then pointed to the Java card specifications for the detailed information and for the content of the evolutions. The other technical standardization evolution that we point out in our document is the eSIM for the IoT published by GSMA that I already introduced. So the concept that we introduced in GSMA, the EIM concept, that is the eSIM IoT Remote Manager, that is a remote server able to manage the content of the embedded SIM by triggering the download of a new profile or managing the profiles that are on board and so on. An application on the device or the embedded SIM called IoT Profile Assistant, or IPA, is used to interact between the eSIM remote provisioning mechanisms and the EIM, and also with the DSM-DP+. And I mean, those are part of the GSMA standard, the IoT, the EIM, and the IPA, and of course the protocol along with the DSM-DP+. On TCA side, we also contributed to the technology by expanding our the specification of the interoperable profile package by adding also lightweight IoT minimal profile. This is a profile specification fitting more the IoT constraints, so optimized in size and in execution, in order to fit devices that are smaller and that can be downloaded over networks that are smaller. The last updates on the standard is related to 3GPP and ETSI. Again, in release 15 and 16, 3GPP and ETSI have introduced a lot of new services also for the Java card developers to support the 5G network. So the standalone support of the 5G has required evolutions in terms of management of the applications and the new services for them, new toolkit events, and so on. In release 17, this has been further enhanced with the 5G SA architecture, big distance, I mean, big evolution versus the LTE technology. The private network and network slicing has been better explained and better, let's say better, there are APIs to provide a better management of it, and new security requirements have been introduced in order to further enhance already, let's say, impressive security of the ETSI and 3GPP services. What is important for Java card developers, you in the document, they are depicted the new toolkit events and the SOAP API for a private network, the GBA API, and the fact that in release 17 and 18, the reference of the Java card specification has been upgraded to 3.1.0, so using new services for developers. Okay, so this is for the, let's say, overview of the standard evolutions, and of course, in this presentation, I give you just, let's say, the high-level description. If you are curious about what I said, the stepping stones document is on the TCA website waiting for you. Let's go a little bit more into the best practices and the recommendation. As anticipated, this list of best practices has been developed by the technical experts of the TCA members community, based mainly on our experience and on what we learned from the field. So they are really things that typically happen to someone else, and in case you follow those rules, you will avoid some specific pitfalls that could create issues to your applications. The first guidance that we provide is about a generic concept on the compilation of your Java Card application. We used here the Java Card version, but as an example, but this is true for all the reference specification that you include in your product. So, of course, in case you need the specific services from a dedicated version of Java Card, of ETSI, or 3GPP, you have to use that specific version. But the suggestion from TCA is to use the minimal Java Card version required by your services that you are developing. For example, if you use really need the services from Java Card 3.1.0 with the new APIs and algorithms introduced in 3.1, then of course you should use the 3.1. But if your application is just using the 3.0.5 services, it's better to compile it against the 3.0.5 specification and runtime environment, because in this way you can download it also on embedded ESIC that are not yet evolved to the 3.1.0, because the cornerstone of the Java Card technology is that is backward compatible. So a 3.0.5 applet can be downloaded on 3.05 and 3.1 USCC. For a 3.1 applet, this is not true. Then the document continues with a series of best practices that are then summarized into the checklist, as we will see. I will not go into the content of all of those. We will see in also other slides summarizing them. Just to say again that we try to give those practices really with the intent of helping the developers and with the capabilities of, let's say, at the end with the final goal of making your application more interoperable and more reliable. As an example, the first point, non-volatile memory update, is based on the fact that our products, so typically all the embedded SIM products, have limited number of writings into the non-volatile memory. After that, the reliability of the non-volatile memory, typically as an example, the flash in flash memory in some of these SIM products is not guaranteed anymore. So basically, if you write too many times inside the flash rather than VM technology in the embedded SIM, the embedded SIM can get broken. In the document, this is explained, and it's also explained that unfortunately, when you develop your application, you don't know on which embedded SIM your application will be downloaded, because it will be part of a profile from a telecom operator, and the profile can be downloaded on an embedded SIM from any supplier. So you need to be a little bit cautious about technological limits and go a little bit on the lower bar of the limit to be sure that you are on the safe side. In addition, it's highlighted which events in toolkit are very frequent, because if you write for every such frequent event, maybe you could reach your threshold of non-volatile memory quite soon. As an example, the status command in Telecom happens at least twice per minute, but its frequency can be increased by other telecom applications. And of course, if you write very frequently inside for every status. At the end, you will write very frequently for in the non-volatile memory, and this is typically a bad practice. We also indicate which APIs can have the consequence of non-volatile memory, because maybe it's not evident to all the application developers that specific APIs provided by ETSI or 3GPP, like the event registration or like the access to specific APIs for the file system, may result in non-volatile memory update. And so it's highlighted which of those APIs have this effect in order to verify that in case you are triggered on your application is triggered quite often, you don't abuse or you don't use at all those kind of APIs. So as you can see, all of this is a detailed technical description that also with the details that operational details for application developers, and with examples to simplify the adoption of those best practices. And the same is true for the stack management, for the field and local variable, and for the management of the execution time and so on. So you can, for each of those, you have information about how you manage it, which is the best practice, how you have a snippet to easy the implementation and so on. And those are typically generic. So it's not only related to the toolkit world, but even for the telecom world, but even if you develop banking application for the embedded SIM, maybe also not for the embedded SIM, you can take benefit for those best practices. Other are a little bit more detailed for the telecom applications. If you are familiar with the telecom ecosystem, 3GPP and ETSI, you can recognize from the names that the usage of menu entries or the file view that are the APIs to access to the file system, the computation of the concealed SUPI, so the SUSI, through specific APIs, are all mechanisms that are dedicated for telecom, so that are more, let's say, using the telecom services. And also for those APIs, it's beneficial to follow specific best practice and guidelines that enhance your interoperability and the quality and reliability of your application. So all of those are also very well explained inside the stepping stones with examples, detailed explanations, and so on. Similarly, to manage the life cycle of the product, it's also relevant to understand what happens when you install an application, when you delete it, which are the operations that you will face, and so on. Also considering that within the embedded SIM ecosystem, some of those operations can happen in different moments, not only during the typical installation of application, but also during the profile download or the profile deletion. So dedicated rules for the embedded SIM are also highlighted that may be not obvious to Java Card developers, but that Java Card developers have to know to make an interoperable and reliable solution. On top of those, let's say, quality and interoperability and reliability applications, we also developed a series of best practice to make the application more secure, as we say. What does it mean? So, of course, your application will execute on a system that is per se secure. No, it's if it is an embedded SIM, it's if it is a recent product, it has ESA certified or common criteria certified with the operating system. It relies on an hardware that is common criteria. So for sure, you are working in one of the most secure environment in the embedded. But even in the most secure environment, the application to take benefit of this security and to protect in an adequate way their secrets has to respect some security guidelines that are common typically between the various eSIM applications, the various eSIM products. So what we did, we collected the security guidelines from the various companies working in TCA, and we explained all of them related to as an example, how you manage the sensitive data of the application to limit or to avoid at all an external hacker to access to the clear content of the value, or how you are let's say stable in executing your application to avoid that with the specific attacks like fault injection, the flow of your application is altered somehow. So, or the new APIs introduced in Java Card 3.0.5 that are the sensitive APIs, so sensitive result APIs. So, I mean, there are a lot of considerations and again, practical suggestions that application developers can embrace in order to make their application more robust. And to make life easier, we collected all of those tips, suggestions, best practices inside a checklist that is, let's say, at the end of the document. The checklist can be used, of course, by application developers to take into account the rules during the applet design and to verify that you have, let's say, followed such rules. By quality and test engineers to verify that those rules have been followed and to design tests around that and so on, but also by customers like telecom operators, because telecom operators can ask application developers if they have respected such mentioned rules in order to have something that is more robust, more secure, and more interoperable. That is the target of our document. This is for the best practices. In addition to that, inside the document and also other services that are provided by TCA are the interoperability testing tools. So over the year, TCA has provided a TCA loader that is a free-to-use tool able to promote interoperable deployment of SIM-based value-added services. We have made also this tool as had several versions in its history. The version 3.0 of the loader provides applet developers with the ability of perform card content management, so application download, deletion, exploration of which applications are on the card, and so on, using on Java Card smart cards using the most common protocols SCP02, SCP03, SCP80, SCP81, and so on. Another important feature of the tool is the capability of compiling applications with a user interface and to save parameters for compilation, for security, and so on, in specific files that can be easily reused. The tool is available for free on TCA website, like the stepping stones. So if you need a tool to manage your embedded SIM, you can download it and use it within Windows and with your PCSC reader directly with your eSIM. In addition to that, also to empower, to further enhance embedded SIM interoperability, TCA has launched with Comprion the TCA Embedded SIM Interoperability Services that enables operators to test how their embedded SIM profiles, which may contain Java Card Applet, so at the end, the Java Card Applet, interact with an extensive range of consumer embedded SIM devices. So Comprion provides this together with TCA provides this service that allows you to test your profile on a wide range of devices. And finally, the interoperable profile package specification by TCA has been evolved with some white papers also you can see, and to introduce the new version 3.3 that also contains evolutions for the IoT. Particularly, it is anticipated before. It has been introduced the concept of lightweight M2M for IoT profile, and this profile is designed in a way. This profile format is defined in a way that it can be contained in a few hundred bytes. So, of course, having a profile of 300 bytes, it's much easier to download it on networks that are naturally that are constrained, like TATEM or NB-IoT, especially if you compare with the typical consumer profile that is tens, if not hundreds of kilobytes. So it's much smaller. And also for devices with constraints in terms of memory, it's of course it's a very beneficial the usage of the IoT profile. For these reasons, and for the fact that we designed it for the IoT market, the version 3.3 is the reference version for the SGP32, so for the standard by GSMA, the new standard by GSMA on the IoT technology. Okay, that is more or less it from me. Here there are the links to our free resources, the TCA stepping stones for Java Card Applet developers, the let's say link for information on interoperable testing services by Comprion, the TCA loader, and the SGP32 white paper that explains the benefit of the new technology. So we are really grateful if you go there and you access to this content, and if you include your let's say those information in your application. Really, the goal of TCA is to have an interoperability enhancement of the technology that we believe it's really an important asset to increase the market, even more market success of the embedded SIM, and to extend it to other ecosystem like the IoT. So thanks a lot for your attention and for the time you dedicated to me. And if you have any question, I'm here to help you.
Thank you, Amedeo, for this very detailed presentation. We are going to open the microphone, but in the meantime, while you all think about questions, we have a few questions on the chat, more or less related to versioning. And so maybe let me take I think this is a worry for a lot of people. The first one would be, for example, what is the recommended minimum Java Card version and Toolkit API version for an applet to have interoperability, or any version can work if the EU ITC has the support of it?
It's it's not an easy question. So, of course, in all the so thank you for the question. Of course, in all the embedded SIM ecosystem, consumer M2M and IoT, the versions of and also inside interoperable profile specification, specific versions of Java Card and the toolkit are referenced, and those I would say are the minimum to that are guaranteed and verified to work with the ecosystem. From a practical standpoint, typically we see that the Java Card 3.0.4 and the API from Toolkit, let's say that these 7 are really very well supported from the market, meaning that embedded SIM at least supports those standards. But we see a bigger evolutions of the Java Card 3.0.5 today already on the market, and we expect the migration through 3.1 in the upcoming few years. So to stay on the safe side, today the suggestion is to use 3.0.4, really I cannot imagine of an embedded SIM not supporting it, but in the very few years, this is evolving probably to 3.1.0.
Okay, thank you. And that was about the Java card and toolkit version. And now there's another one, but more related to the 3GPP release. And this one is, in case we are asked to load an applet compiled with release 5 onto an eSIM, what behavior can we expect from the applet?
Okay, so release 5 is theme toolkit. So we are talking about 99, I think, or 98. I was at high school at that time. So, of course, it is something that is supported by the TCA interoperable profile, the capability of downloading applications with release 5 APIs. And it's also tested by our test suites, but it's a legacy. So as an example, the SIM technology, so the GSM authentication is not supported anymore. Basically, we do not, let's say, in our document, in the stepping stones, we have some dedicated information for that, and we encourage people to migrate to the UICC APIs, so to the 3GPP. But let's say your functionalities have been tested, and also for these 5 have been tested and verified during the certification program of the embedded SIM. So we don't anticipate necessarily malfunctioning if you use the release 5. But it's really advised to migrate to the, at least to the toolkit API from release 6, so from the 3G.
And thank you, Amedeo. And it looks like people have a lot of legacy, because there's another question about here again, it's Java Card version, and they mentioned applet compile for Java Card 2.1. Will they run on smart cards with Java Card 3.1? And so what's your advice on this?
Yeah, to my knowledge, an applet for Java Card 2, I'm not sure if it works with the Java Card 3 because the backward compatibility, but it's more generally, maybe you can answer better than me on this. I recall that the backward compatibility for Java Card is guaranteed only if the minor version changes, not also the major version. So
I see that from the question, I think that a big hassle for the interoperability is the support of the many versions and the legacy, and this is probably not helping and is causing a lot of work. And does your stepping stone have a clear guideline on this that can help people?
Yes, so that's why we also highlighted the various versions of the Java card of ETSI and so on. And yes, you can find inside of the document the list of packages and the list of versions that help on understanding which are at least the expectations of working from using such legacy applications.
And beyond, I know the TCA has a lot of statistics on market penetration and everything, but you have also statistics on what versions of the Java card, for example, or API are in the market to help applet developers make the decision?
I have to check if this specific information is present in our report. For sure, we provide from time to time some educational information about, let's say, the expectation level of support on that. I don't know if in our report we also indicate the version of Java card. I don't think so, but in say maybe less with the numbers, but more with concept, we have several educational information that can for sure support developers in looking for the right version and understanding what they will expect on the field at the end.
Okay. And now we can open the microphone. Do you have any questions directly to from the audience?
Yes, one question. TCA is having any utility or tool for network slicing and private network feature?
We don't have an utility or tool for that, but we have some white paper explaining how to manage the 5G features, including network slicing and private network features. It's of course an interesting point. Maybe you can provide me some information about what could be the expectation from the industry, and we can evaluate whether it is useful for our community to deploy such and develop such a support for the industry.
Okay, okay, thank you.
You're welcome.
Any other question? Don't be shy. I have one from myself. You mentioned the secure application for mobile, and I know all the work presented so far, and it's mostly around applet for MNO profiles and telecom applications. But with the SAM, this could be anything from ID to banking to whatever. And is the TCA going to address also stepping stones for this type of application, or what's your take on this? Should any vertical take care of it, or what you see would happen?
Sure. So it's a very important question. So for sure, in the past, we already challenged some of the those technologies, like especially with the stepping stones on NFC that we did a few years ago. That is available on our website. At that time, it was more for the SWP SIM, so for the SIM that was also supporting NFC connectivity, but at the end the guidelines are very similar. The best practices we collect are also split in various families, and some of those are actually independent from the telecom ecosystem, so they are not really related to the telecom applications, but in general for all applications that are hosted by an embedded SIM. So at the end, they are definitely useful also for them. And finally, the TCA loader, in addition to supporting telecom protocols like SCP80 or SCP81 to perform card content management, it also supports SCP03 or SCP02 that are typically used by banking cards or ID cards and so on to make the card content management. So also the TCA loader can be used even with cards that are not telecom to test your applications and then deploy that inside the SAM profile.
Okay, thank you. Do we have any questions for Amedeo? No. So anyway, if you have any question, you can follow up directly with Amedeo. Thank you for attending this first webinar of the session. There will be a second session from Amedeo this afternoon for the America regions and Europe. And if you want to pass the word to your colleagues, this has been recorded. It will be on our YouTube channel, and please don't forget to check out the upcoming webinars of the season. We have very great and solid agenda and presentation. I look forward meeting you again for those webinars. And with this, good afternoon or good evening or good morning, everyone, and hope to meet you soon for another webinar. Bye now.
Thank you very much for your time, for the great opportunity.
Thank you, Amedeo.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, Amedeo.